Okay, we're on to big topic number 3 for this class, which is digital video. So let's start just with a little bit of what video is. And I think this is no surprise to anybody that, hey, we call movies motion pictures, right? That video is essentially images, right? Individual photos or images, just a lot of them. A lot of them that then are changing, sometimes very slightly, over time. It'll be a lot of the same methods and representations as images, just more of them, right? And potentially lots more of them, right? There's a reason that in the early days of digital media, right, particularly, when we're talking about sharing things online, whatever, that we started with things like audio, moved to images, and then more recently have moved to video and being able to scale up to video. It is that much larger and that much more computationally intensive. So let's start with just a little bit of history, right? How we went from still photographs to motion pictures, and about the phenomena that really, this perceptual phenomena, like almost every other thing we've talked about thus far in this class, it relates to human perception, and or maybe a facet of human perception. In this case, it's particularly persistence of vision, right? Which is what allows us to see a bunch of still images as moving pictures. So let's start with kind of the earliest example, or one of the earliest examples we know of moving pictures, right? Uh, this photographer slash scientist named Edward Muybridge, right? This is the late 19th century, 1878. And he wanted to settle a bet, right? I mean, horses were prevalent at the time. That's how you got around. So for a horse moving fast in full gallop, is there ever a time where all four of the horse's hooves are off the ground, right? So basically, or is there at least one of them always touching the ground at any point in time, right? So he wanted to settle a bet, made a bet with somebody. And so he decided to find the actual answers. What he would do is use a series of still cameras. Apparently he had the means to have multiple still frame cameras just in rapid succession. So firing them off, dot, 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 right? Very quickly. And this is, again, sort of one of the first examples we have this, but again, a profound example, right? So here are some of the images that he took. And so he took a series of, about 10 different frames, I think, maybe a little more, that others have then since animated into this movie here. And you can see, yeah, you can see that there's a particular frame where all four hooves are off the ground. So again, he was trying to win a bet, but in the end invented movies. So again, this is the late 19th century, obviously before photography was super common, before color photography, I think, had been invented even, and certainly before there were regular motion picture cameras. But that's the progenitor of today's video capture, video cameras, and video processing, right? And in fact, this kind of technique of using multiple still frame photo cameras to kind of create a motion picture effect is still common. It's still used. Well, I mean, hopefully most of you have seen The Matrix, because one, it's an awesome film, but two, it was really a groundbreaking film in so many ways. Now it's more than 20 years old, but in one of the sort of seminal scenes in The Matrix, where we pan around Keanu Reeves, right? This is bullet time. This is one of the first instances of this effect, was actually done using a series of still frame digital SLR cameras, DSLRs, but they formed this ring, and then by shooting cameras in rapid succession around the ring, created this sort of flying camera effect, right? So just one more time, I'm gonna just go around. You can see these are the frames captured by those different cameras. And of course, that's what was edited together then to create this, this scene, which is a meme, um, of Keanu dodging, the bullets from the agent. Right? Obviously, with a lot of post-processing to do that. So, and again, we have, of course, even more advanced ways of doing that now. But in thinking about video as just a series of changing images, right? Maybe that brings up a couple of starter questions, right? The first might be, how often do we need to change those images, right? And how should we represent that change, right? How often is it, and what sort of units, what sort of measures should we use to indicate that period of change, or the timing of that change? So, a lot of times, let's think about this in terms of how many images per second, right? How many times do we need to change that image per second? So I'm going to give a couple of very, very basic, simple examples. Let's take this ball and let's move it around, and starting at one change or one frame per second, right? And yeah, you might say, well, okay, I get what you're going for, right? The ball's moving, but no one's under the illusion that that ball's actually moving. It's sort of blinking, right, from one spot to another. Right? What about 2 frames per second? Well, it's just twice as fast, right? Yeah, I mean, again, I think maybe you get what I'm going for, but it's like it still seems very blinky, right? Like I see it moving from one spot to the other instantaneously. Let's try faster, 5 frames per second. Maybe 10 frames per second. Let's try that again. So maybe, and again, this is going to get encoded into video and Zoom. And so maybe you start to see, I mean, again, 10 frames per second is not fast, but maybe you start to see that there's some like virtual motion there. Maybe, not really, right? So this is due to, again, an artifact in our perception, right? In our eyes or our visual system called persistence of vision, right? Which is that in your eye, right, there's sort of an after image, or that image sort of stays imprinted on your eye for about a 25th of a second. And there have been many, many experiments to explore that, right? So that means that, basically, if we change the image, right, in let's say a 25th of a second, around there or less, right, then it's going to seem that things are changing, things are moving without kind of interruption, without blinking or flickering, things like that. Persistence of vision is what allows, for example, time lapses to seem like they're moving. Right. So here's one from a building you may recognize. Right. So this is a time lapse from across Market Street throughout the construction of the Bassone building. Right. I know it's been a while since we actually set foot in that building, but this was, I think, a photo a day over, many, many days of construction, and just again sequenced into a movie. And so you can start to see the, step by step, the building taking shape. And again, some really poor quality webcam. This is, maybe like close to 20 years ago, 18 years ago. You can see the outline of the building there, all the cranes moving in and out. And in a little bit, yes, then you'll see the framing of the sort of glass atrium. Which is the more familiar look we see on Market Street. So these frames are going by, maybe around 20, 30 frames per second. And it gives that illusion, right? Even though these images were taken, about a day apart. Well, I think at the same time every day. So exactly a day apart, right? Sequencing them at about, 25, 30 frames per second gives us this impression that things are moving and being, rapidly constructed before our eyes. So you can watch the whole video in the presentation online. Persistence of vision is also what allows for animation to have its impact or its effect on us. So where each frame of an animation is generated independently, but then again sequenced. And so we have a little bit of movement, a little bit of motion from frame to frame. Some of you may be familiar with Wallace and Gromit, which is very famous animated claymation. So each of their figures are actually molded out of clay and then moved slightly from frame to frame, right? And creates entire shows and movies using this method. Extraordinarily time consuming, very, very tedious, but some really, really amazing stuff. So I can't show it here in this video. I've given you a YouTube link that you can go see a video if you're not familiar with an example. Now, these sorts of like stop motion animations aren't usually done at a full, let's say 25, 30 frames per second, just because it's so tedious, right? So you take little shortcuts, you slow it down a little bit. So it's not meant to look like completely smooth motion, but again, we are able to get that sense of movement. So this is, of course, also the theme of our project for this section of the class, which is to create a stop motion video, a video out of a sequence of individual frames. So for some inspiration, I've linked to this video, also available on YouTube, or you can watch it in the presentation slides separately. This is, again, like almost 15 years ago, but this was a really, really fun 5-minute video where these two guys sort of turn into superheroes and have a big fight. But it's all done with stop motion photography, so they can do things like fly and float and do telekinesis and all sorts of things. So I encourage you to watch that. It's a lot of fun, and maybe get some ideas of what you could do for your stop motion video as well. And you'll see from this video as well that it's not at a full 30 frames per second, that it's probably much less than that, like maybe 10 to 15 frames per second. And you still get the illusion that, hey, stuff is happening. All right. So some common frame rates that are found in certainly in movies and in digital video are 24 frames per second. That's sort of the standard for filmmaking for almost a century. Like things are shot at 24 frames per second. Even when we're filming with digital cameras now, 24 frames per second is pretty standard. Analog video, like early television, before digital TV, was filmed at mostly very close to 30 frames per second, or sometimes 29.97 frames per second for reasons that aren't really all that interesting and not worth going into, but about 30 frames per second. And of course, now with digital video, we have, and modern displays, we have the ability to present frames at almost any frame rate that you can imagine. And so you'll see video content being generated at slow frame rates, like for the sort of stop motion animation, 24 frames per second to reproduce what the filmmaker intended, or even 30, 60, or even higher frames per second that give a lot of flexibility for different uses, as we'll see. I mean, you can also shoot at much higher frame rates if you'd want to. So that is what usually is used, the process we use to create slow motion, or slow-mo. I mean, your phone may even be able to capture at 100 frames per second, 120, 240 frames per second to get that sort of super slow-mo effect. There used to be a TV show on Discovery Channel called Time Warp, which was all about this super high speed photography or video capture. So again, I'm not going to show the videos right here, but I'll link to them so you can watch them. There's almost all of them are online, but this was one person getting hit in the face by a water balloon. There's one capturing droplets of water and what that really looks like. Of course, another common use is to look at bullets in motion. And again, this is a very, very common technique now. But again, the idea is that you can capture at much higher frame rates and slow down time, and then play back at lower frame rates to sort of give that slow motion or stopping in time effect. So there is a cost, of course, to that, because as I alluded to earlier, right, these are each an image, right? And we know approximately what the size of, let's say, a photograph is. So if you're shooting something, at reasonably good resolution, let's say 1080p, which is 1920 by 1080 pixels, right? Each image is that size, right? A couple megapixels. But and we can compress each of those individually, but then for a video, you multiply that by the total number of frames. So if you're shooting 30 frames per second, right, for 1 second of video, your video is already 30 times the size of just, let's say, the still image of that size, right? And that's just for 1 second. These numbers add up very, very quickly, right? So it's the dimensions of your image times the number of frames, or broken down a little further, right? It's the dimensions times the length of your video in seconds times the number of frames per second. Right, so let's say you're creating, whatever, a 10-second video, right? Then, if you're shooting 10 frames per second, that's already 100 frames, 100 images. If you're shooting at 100 frames per second, right? 100 frames per second, that's already 1,000 images, right? So that's for more higher speeds, right? And if you're capturing at super slow-mo, hundreds of frames per second, that adds up very, very, very quickly. So in future topics, we'll talk about how we can perhaps more efficiently represent that rather than storing it as just a bunch of still images. But I just wanted to give you a sense. Yeah, video files are going to be big, right? They're going to be much bigger than photos. And this is why video streams are bigger and why video editing requires much more storage space and processing power. But we'll get to that in future topics. See you then.